that defines a set of inputs and a set of commands, right? And then it also provides the specification, formatting that is, and tagging of data types for the outputs that your CLI program produces for that given set of commands. And then you also provide the separate piece. One piece is the XML spec. The other piece is the binary that runs in that aforementioned user world environment that actually carries out the command. So you're providing a specification for commands and something that actually goes and does it. So the command that actually goes and does it has to be conform. It has to produce XML output that is conformant to a developer specification, and I'll talk a little bit more about, if you're concerned about that, how you might make that process a little bit easier. This produces a plugin. The plugin runs on the host, and it can interact with the host. What do I mean by that? It means that it can talk to your kernel modules that are running on ESXi. It can talk to drivers. It can issue ioctls, stuff like that. The interface wrapper is that ESX CLI client I was mentioning. It can run remotely or on the local host, and then users can be able to take advantage of your plugin when it's been installed. So the ESX CLI architecture on ESXi looks like this. So you have an ESX CLI client. Notice that it's either running on the local host from the ESXi shell, or it's running remotely. In this case, it actually runs from vCenter. So the type of operations you would issue here are diagnostic type operations and configuration. You might want to configure an HBA, properties of a NIC, maybe get some debug data about that NIC, things like that, or your HBA. This talks to our ESX CLI framework. The framework then, much like SIM, keeps track of the plugins and commands that are available, and has sort of a directory of things that are there. Once you issue a command or ask a question about a command,